This is for test number 6 in AP Calculus AB. We start with this question: find the particular solution. We are given here the derivative y prime equals 2x, and we're given a point on the original, the point 0, 3, x equals 0, y equals 3. And we want to take that information and find the original equation. So we start here with y prime equals 2x. To get to the original, we take the antiderivative. So y will be equal to x squared plus c. Now we use this point right here to solve for the c. Whatever's in parentheses goes in for 0, and what it equals to goes in for y. So we get 3 equals c. Now please don't stop there. C is not your final answer. The equation is. So take the 3, plug it in for the c, and then you have your final answer. So when it asks for the particular solution, it's just asking you to find the original function and to solve for c. Now it says find f if f prime is equal to 3x to the negative 1/2 and f of 4 is equal to 5. Same type of problem as number 1. We're starting with the derivative, trying to find the original including the c. So we start by adding 1 to the exponent, then dividing by that number. So I get 6x to the 1/2 plus c is equal to f of x. Now I plug in the point that's given to me. 5 goes in for f of x, 4 goes in for x. 4 to the 1/2 is 2. 6 times 2 is 12. So we're going to get c equals negative 7. So our final answer is 6x to the 1/2 minus 7. You can also write that as 6 square root of x minus 7. Number 3, similar problem, only we're having to do it twice because we're starting with the second derivative right here. Then we're given information about the first derivative to solve for the first c and about the original to solve for the second c. So I take the antiderivative one time to get to the first derivative, and that's 1/2 x squared plus 2x plus c. And then use the information given to me right here, since I'm in the first derivative, to solve for that c. So I do 3 equals 1/2 x squared, 0 squared, 2 times 0 plus c. So we get 3 equals c. So that tells us that the first derivative is 1/2 x squared plus 2x plus 3. But I have to take the antiderivative again to get to the original. That'll give me 1/6 x cubed plus x squared plus 3x plus c. Then we plug zeros in for all the x's, negative 1 in for the y. And we get that c is equal to negative 1. So our final answer is that f of x is 1/6 x cubed plus x squared plus 3x minus 1. The fourth one, we're switching gears and talking about the properties of integrals. So we're told here that the integral from 0 to 7 is 6, and the integral from 5 to 7 is negative 2. I find it easiest to just draw a number line for myself. Let me start over there, sorry about that. Look at that again. 0 to 7, and then 5 to 7. Okay, so the whole thing, 0 to 7, this entire thing is 6. 5 to 7, this little piece, is negative 2. So their question to us is, what is the area from 0 to 5? So you just have to figure out what plus negative 2 gives you 6, and that of course would be 8. Okay, similar idea here. We're using the properties of integrals. So it says that given that the area from negative 2 to positive 4 is 11, what is the area from 4 to negative 2 of 3 times f of x? Well, we have two things going on here. If you look at the boundaries, they've been flipped over. So we need to add a negative to our answer. Also, we're multiplying by 3, so we need to do 3 times 11. So our final answer will be negative 33. Again, we multiplied by 3, so that did 3 times 11 is 33. The boundaries have been flipped, so that makes it negative. Number 6, I'm going to use the number line again. We're going from 0 to 5 and then 2 to 5. So from 0 to 5, we know that entire thing is 17. It's given to me right up here. And then from 2 to 5, we know it's equal to 15. So just looking at our numbers here, this has to be a 2, but look very carefully at what they ask for. They don't simply ask for the area from 0 to 2. They ask for double that area, so we need to double it to 4. But they also have swapped the boundaries on us, because it should be 0 to 2, which means it would be a negative 4. So this area right here is 2, but we have to double that area and make it negative because the boundaries have switched. Alright, number 7. This is the first fundamental theorem of calculus. Anytime you see this integral sign, you need to take an antiderivative. So the antiderivative of 2x minus 1 is x squared minus x. And then we plug in the top number minus the bottom number. 3 squared is 9. Negative 1 squared is positive 1. So we end up with 6 minus 2, which is equal to 4. So take the antiderivative, plug the top number into your answer, subtract, then plug the bottom number into your answer. Okay, same process here. We have the integral from 0 to 8 of the cube root of x. I'm going to rewrite this as x to the 1/3 instead of the cube root. Add 1 to the exponent, divide by that number. We're going to go from 0 to 8. So I plug in 8. Okay, the cube root of 8 is 2. 2 to the 4th is 16. 16 times 3/4 is 12. And that's just 0. So our answer is 12. Number 9, still the same process. Let's rewrite 1 over x cubed as x to the negative 3. Add 1 to the exponent, divide by that number. So I'm actually going to find that easier personally to write that as negative 1 over 2x squared, just because I'm doing it by hand. If you're doing it in the calculator, it's not a big deal either way. But I just move that x down to the bottom. So then I plug in the top number minus the bottom number. 4 squared is 16 times 2. We have negative 1 over 32 plus 1/2. I'm going to double check this, but I think we're going to get positive 15 over 32. Give me just a second to double check that one. Okay, that is correct. 15 over 32, or the decimal, if you prefer, is 0.46875. Alright, number 10, still the same process. This is the first fundamental theorem of calculus. It's very important. We take the antiderivative of cosine, which is sine. Then we plug in the top number minus the bottom number. Sine of pi over 2 is 1. Sine of pi over 4 is square root of 2 over 2. So you can leave the answer like that, or if you prefer the decimal, it is 0.293 if you're rounding. Actually, I should have it like that since it's approximately that number. Alright, I think I'm going to pause here and I'll tackle this one at the beginning of the next video.